Although Revit allows you to create a concrete slab with a metal deck profile, which looks great in sections and details, in the 3D view, it remains a flat slab. In this video, Senior Revit will show you how to use a family to correctly model a composite slab, covering these three most common types. Plus, if the slab requires reinforcement, you don't need to model it manually, as the reinforcing bars appear automatically in 2D views. For instance, a few years ago, Senior Revit made this render using this exact family. So, stick around while we show you how to use it and where to download this amazing family.
Hi everyone! First, I'll demonstrate how the built-in Revit metal deck system works. If you already know how it works and want to skip straight to the correct 3D modelling method, you can jump to the timestamp shown here. Typically, the way Revit allow you to model a steel deck slab is by adding a standard concrete slab where the thickness accounts for the slab's total depth. In this case, you can see I'm setting it to 120 millimeters. Of course, this depends on the specific assembly, but essentially it combines the depth of the metal decking and the concrete topping layer. To define the shape, you can insert an extra line, change its type to structural deck, and select a deck profile for the material. If you started your project using a construction or structural template, this step will be straightforward and the default Revit deck profiles will appear below. The construction template includes only one generic type, whereas the structural template offers a few more options. If you enable the preview using this button, you can see the cross-section that will theoretically be generated. However, as you likely know, once you accept the changes and return to the 3D model, those deck ribs are not visible. They only appear when you generate a section view. And of course, the metal decking itself isn't visible in either section or 3D views. But if you want to take your Revit models to the next level, you can create this type of slab, which appears completely in 3D, and also view the metal sheet representation. To do this, instead of creating a different slab type, I'm going to use the same simple slab used for the traditional method, but this time without including the structural deck layer. In this case, I'm going to place these decking families, which come in various profiles, and are designed to sit atop any slab. This decking is placed at the bottom of the slab, effectively removing the unused concrete volume. Another advantage of using this family instead of the traditional method is that it gives you the exact concrete volume by subtracting the volume occupied by the metal deck profile. As an example, I've added the most common type of metal decking system, the one you see here. Since the name varies by country, I'll simply refer to it as Open Rib Composite Deck. At the time of recording this video, there are three available types: open rib, deep rib, used for long industrial spans, and Re-entrant composite deck, also known as trapezoidal deck. However, be sure to check the link at the end of the video or in the description, as more profiles may have been added by the time you watch this. And if there's a specific one you'd like me to add, let me know via the email address shown here. As you can see, you simply place this family on the top face of the slab. From there, just adjust the slab thickness and add the reinforcement mesh that is typically required. This specific version generally does not require reinforcing steel, but I have added an option to add maximum 2 bars. To modify this, simply select it, go to Edit Type, and specify the number of bars per rib and the bar diameter. It is worth noting that the bar diameter will appear based on your bar diameter unit settings. You can find these under Manage, Project Units, Structural, Discipline. For the deep rib family, only a single bar is used, so here you can only modify the diameter or choose not to display it. Returning to the floor plan, you will notice the family isn't visible in this view, so I will adjust the view graphics to apply a slight transparency, around 10% or 20%, to the floors. Now we can see where the decking is positioned. Selecting the slab directly can be tricky, so I recommend using a selection window instead. Once selected, you can adjust its length using these blue arrows. Drag them to the opposite ends of the slab to complete the decking placement. Open a 3D view, and you will be able to see the fully modelled section. If you select the slab and hide it temporarily, you can view just the structural decking. Keep in mind that this decking belongs to the generic models category, so you must have that category enabled to see it. So far, we have simply created a single panel. To create the complete floor assembly, however, we need to repeat the process. If you select the panel family and click Edit Type, you will see a parameter named Module Width. This represents the spacing required between panels to maintain visual continuity. If you are dealing with a simple square slab requiring no adjustments, you can simply create an array using the module width as the spacing interval. However, such straightforward cases are rare. We often encounter openings for staircases, and in some instances, the slab is not oriented at a 90-degree angle. Therefore, it is best to model the panels individually in these situations. Let's start with a case of a slab with an angled edge, like the one shown here. To do this, I will draw a temporary line starting from the top edge of the slab and align the first panel to that line. Next, I select the panel. Looking at the properties palette, I can see that there are two variations available for this panel type, one without a cut and another with a diagonal cut. I select the panel with the diagonal cut, which defaults to a 10-degree angle. You can modify this value via Edit Type, either by changing it directly or by creating a new type for each specific angle if you're working with multiple slabs at different angles. I copy a panel, spacing it according to the module width value, and once again go to Edit Type. This time I look for the cut offset parameter, which tells me how far to shift the panel so it aligns correctly with the previous one. I note this value and return to the floor plan view. I select the second panel and move it down by that same amount, then adjust its height at the bottom edge. I repeat this process until the entire slab is covered. If we switch to a 3D view and hide the concrete, we can see the decking sheet cut correctly. Now imagine we need an opening in the middle of the slab for utilities or a staircase. For these cases, we have a void version of each family. Simply look for the family with the same name but ending in void cut. After placing all the system's decking sheets, let's create a small opening somewhere, for example right here, to allow for utilities. First, I modify the full sheets on one side to fit the opening, and on the other side, I simply place a new sheet, adjusting its length accordingly. Then, for the opening itself, I place the void version of the same family as I mentioned earlier. I adjust the length and I set the width using these two lines. And that's it. As you can see in the 3D view, there is no need to modify the slab boundary or add a separate slab opening. Even if the opening is larger and spans two sheets, we can do something similar. First, we modify the full sheets in the same way. Here we can take the sheet on this side and extend the cut to the slab edge, while extending the cut on the other sheet to this end. This way, the two cuts work together. Finally, if the opening is larger, say for a staircase, it makes sense to modify the slab boundary itself. We can also use the void cut version of the family to make adjustments where the opening overlaps with the staircase area. Remember, I've included a link in the video description to download the ready-to-use family. And if you'd like to see how to create perfect, realistic 3D roof decking of this type, check out this video. See you in the next video.